looking at an experimental circuit to make a kind of, say, low battery warning for these two batteries that are in series. So they are on 24 volts, and at the moment via a converter I'm taking out 220 volts. The converter is in the kitchen because it has a blower inside and I don't want that sound in my living room anyway. Two batteries here, and this is that circuit. In fact, very simple. I published it earlier on YouTube and I made now a 24 volts application. The video on YouTube was for a 12 volt battery, but now it is 24 volts. Anyway, I'm looking here at the meter at the same time, and the good thing and strange thing of this unit is that it starts to protest when the voltage gets too low. So it's kind of a frog sound of a frog when the battery gets too low, and that has everything to do, you can hear it now. This, by the way, has everything to do with the fact that at the moment I'm also driving here out of the 230 volts a computer that's in my living room. And when that computer takes too much current, for instance on a blank screen or a white screen, this unit starts to protest. So that's what you heard now. I cannot demonstrate at the moment, of course, what's on my computer, but anyway, all these things, that's important to tell, work on 1/100th of a volt. And that's the reason why I've used here this meter that gives out here in the reading a hundredth of a volt. And here you see how the voltage dropped down this day, today, 13 March 2020, after quite a few sunshine in the Netherlands during the day. So the voltage dropped down from 26.23 volts to 25.03 volts, at the moment 25.01 volts. I always take very conservative, use conservative ideas when working with lead acid batteries. They may never be, say, too high depleted. That's very important. So there is here on the back side a inverter that will switch off after a certain time, but I am more conservative and I want to make a low battery warning for the 24 volt battery here that switches off somewhat more earlier. So not on the voltage of which the inverter switches off. So 24.8 is my aim. I think in that case the battery is almost half depleted. 24 volt battery, half depleted, but I have to do more experiments before I will publish this circuit on YouTube. Anyway, working with lead acid batteries is a real science. That's my experience over the, say, 12 years that I've worked with them, or 15 years, even 15 years. And for instance, when you do measurements on a lead acid battery, you need this meter. That shows what happens on 1/100th of a volt anyway. So, that was more or less all to tell. I want to develop this circuit further. So, when the first click comes, you can see when it clicks here, the LED flashes. And of course, with that flash, you can drive a digital circuit so that on a certain moment, when the first click appears, a Schmidt trigger circuit starts to be active and give out a constantly beep signal or so. That will perhaps be the second development. Anyway, this is the first schematic circuit, and well, I think it works quite well. It took, by the way, many hours to make this working, and you can see it here all. Everything is experimental. Long wiring, zener diodes, different resistors, etc., etc.